Thank you for presenting me. Today I'll talk to you about how VictoriaMetrics scales to high loads, such as data ingestion of 100 million samples per second. Do you hear me? Yeah, it's okay. Okay. I'm Aliaksandr Valialkin. I like writing programs in Go. That's why VictoriaMetrics is written in Go. I like writing simple and clear code, and I hate over-engineered, complicated code and bloated dependencies. Unfortunately, nowadays it's a quite common problem in software development. And I like performance optimizations. That's why I created multiple performance-oriented packages, libraries, and applications, such as FastHTTP, FastJSON, Quick Template, and so on. And you can visit my GitHub and see all these projects and explore them. So what is VictoriaMetrics? VictoriaMetrics is an open source monitoring solution and time series database. The time series database is a database for storing collected metrics and later analyzing them. It supports many popular data ingestion protocols, such as InfluxDB, Prometheus, OpenTestDB, Graphite, Datadog, CSV, and so on. It also can be used as some kind of drop-in replacement for Prometheus. This means that it can discover and scrape Prometheus targets, and it understands also Prometheus configs, and it also can discover and scrape targets in Kubernetes like Prometheus does. One of the main features of VictoriaMetrics is it is easy to configure and operate compared to other solutions. Another main feature is low resource usage, and the connected issue is high performance compared to other solutions on the market. VictoriaMetrics has two kinds, a single node version and a cluster version. The single node version scales vertically. This means you can migrate a single node version to a computer with more CPU, more memory, more disks, and VictoriaMetrics will scale on this hardware and will efficiently scale on this hardware. This means if you migrate from 2 CPUs to 4 CPUs, then it's likely its capacity and performance will increase twice. And the cluster version of VictoriaMetrics scales horizontally. This means it can scale to any number of host computers it runs in a cluster. And both versions, single node and cluster version of VictoriaMetrics, share the same core code, and they differ only with the code which is responsible for communication between cluster nodes over network, because this code isn't needed in a single node version of VictoriaMetrics. Let's look at a few optimizations which allow scaling performance of VictoriaMetrics, and we'll start from single node version and the data ingestion path. At data ingestion, a client connects to VictoriaMetrics and over any supported protocol and sends data to VictoriaMetrics, and VictoriaMetrics reads the data in some kinds of blocks over this connection, and then it parses these blocks on available CPUs. This means that it just reads data from network connection, and then puts these blocks to work quick queue for available CPUs, and every CPU can parse and process this data in parallel. This allows increasing performance of data ingestion on data ingestion path. After the blocks are parsed, they are put into in-memory buffers, and VictoriaMetrics maintains multiple independent in-memory buffers in order to avoid single global lock, and which usually reduces the scalability of the system on multi-core, multi-CPU system. And later, these in-memory buffers periodically are flushed to disk, and VictoriaMetrics stores data in log structure to merge like data structure and disk, and every buffer is written to disk in parallel on available CPU cores. This also increases the scalability of data ingestion path of VictoriaMetrics. Let's look at the querying path. As I mentioned in the previous slides, VictoriaMetrics stores data in blocks, and these blocks are independent. This means these blocks can be created and unpacked and processed independently of each other. Every time series consists of such blocks, and when during the query VictoriaMetrics reads the needed blocks, then it unpacks these blocks because the data is stored on disk in compressed form, and this unpacking is performed also on all the available cores, CPU cores, I mean. And after that, when the blocks are unpacked, they are assembled into distinct time series, and every time series is also processed in parallel on all the available CPU cores. This allows scaling query performance with the number of CPU cores in VictoriaMetrics. As you know, the performance of single node version is limited by resources available on a single host, and a single host cannot scale infinitely. It has limited resources, CPU, RAM, disk. According to our benchmarks, a single node version of VictoriaMetrics can scale to the following numbers. It can accept incoming data at the speed of 300,000 metrics or samples per second per CPU core. This means if you have 10 CPU cores, then the data ingestion performance, the theoretical data ingestion performance of single node VictoriaMetrics will reach 3 million samples per second. It also scales with the number of active time series. It needs around 1 gigabyte of memory per each million of active time series which are ingested to VictoriaMetrics. And as for querying path, it is also optimized, and it can process up to 50 million of samples per second per CPU core during querying. This means if you read the title of the presentation, 100 million samples per second, if we don't mention that this is related to data ingestion path, then we can say that VictoriaMetrics can reach such speed, 100 million samples per second on 2 CPU cores during querying on single node version. And the production numbers are quite different. They are usually lower but for obvious reasons, but they are also impressive. According to our users and customers, we know that the single node version of VictoriaMetrics can handle up to 2 million samples per second. It can handle 100 million of active time series. It can process samples during querying at the speed of 1 billion samples per second, and it can store up to 15 billions, this 15,000 of millions, 15 trillions, this 15,000 of billions is a huge number of samples in the database without any issues, and on a single host. Obviously, this is a beefy host, but it works. Let's look at the optimizations, scalability optimizations in a VictoriaMetrics cluster. And at first, let's look which components does cluster has. The cluster contains of 3 components. The first component is VM insert. It is responsible for receiving data from clients. You can see on the graph that incoming data goes to an ordinary HTTP load balancer, for instance, Nginx, or specialized load balancers such as VMOs. This is a part of VictoriaMetrics. And the ordinary load balancer just spreads incoming requests with data among available insert nodes. Then there is a VM select component. It is responsible for processing incoming queries. It also works over HTTP protocol. Incoming queries go to ordinary HTTP load balancer. HTTP load balancer spreads these queries across available select nodes. And the third component, the most important component, is VM storage. It is responsible for storing the data and for returning data, the required data back to VM select components during queries. Each component, VM insert, storage, and select, can scale independently and can run on the most suitable hardware. There is no need to run these components on the same hardware. You can choose the most suitable hardware and choose the most suitable number of nodes per each component. They're independent. Let's look at how VictoriaMetrics cluster scales data ingestion path. As I already said, the data goes through load balancer, and load balancer spreads incoming data across available insert nodes. This means that the performance of data ingestion path scales with the number of available insert nodes. When in every insert node spreads incoming data among available storage nodes, it uses consistent hashing for this over time series. This means that every unique time series, it tries to write every unique time series only to a single storage node. And this scales data ingestion path with the number of storage nodes. You increase the number of storage nodes, and the data ingestion path also increases. The performance of data ingestion path increases. As for querying path, it also increases because of the load balancer and the number of select nodes. And VM select also queries the data from every storage node during for every incoming query. This data is queried in parallel, and then it processes data. And this means that the query performance also scales with the number of available storage nodes, and query performance also scales with the number of CPU cores available at a single select node where the incoming query is processed. Because of select node uses the same core code as the single node version of VictoriaMetrics, as I described before. Which scalability limits does cluster version of VictoriaMetrics has? Maybe it's CPU. The answer is no, because you can add more nodes in the cluster with more CPU, and the performance and scalability of the cluster improves. Probably this memory. The answer also no, because of the same reasons. You just add more storage nodes with more memory, and the capacity of the cluster increases. The same applies to disk, because you can add more disks or higher performance disks, and the performance also scales. And the obvious answer is the network. Yes, because cluster components communicate with each other over network, and the network can reach its performance limits, and after that point you cannot scale more. So let's look how far the performance can scale on cluster version of VictoriaMetrics. That's why we conducted so-called 100 million benchmark, which answers the following questions. Can VictoriaMetrics cluster accept 100 million samples per second in production? And the second question is, can VictoriaMetrics accept 1 billion of active time series, process 1 billion of active time series, and how much resources does this VictoriaMetrics cluster need? How to conduct such benchmark? Unfortunately, on the market, there is no a benchmark framework for time series databases or for monitoring solutions, which can reflect production work, can generate production-like workload. There are many other solutions which generate some kind of artificial data or limited benchmark. Such benchmarking usually called benchmarking because every vendor tries to highlight their solution compared to competitors, using various tricks such as artificial data, such as limited amounts of data, limited benchmark duration, special configs, or using optimized hardware. And we decided to go another path and created Prometheus benchmark. This framework which allows testing Prometheus-like systems on production-like data. It uses production-like data. How it works? It contains of load generator which runs node exporter. This most common exporter which is used in Prometheus ecosystem. It collects host metrics such as CPU usage, RAM usage, disk usage, network usage, and so on. This load generator collects real metrics from node exporter and then pushes the collected metrics to Prometheus-like systems such as VictoriaMetrics. It supports all other systems such as Prometheus itself, Tanos, Cortex, Mimir, and so on. On the other hand, it also allows running typical queries, production-like queries against the collected data using alerting rules from node exporter. And this is the link for this benchmark. It is located on GitHub. So our requirements for this benchmark are the stable ingestion rate at 100 samples per second. What means stable is this means that the ingestion rate should not be jumpy because spikes during the ingestion rate usually means that something goes wrong in the system, and they are treated usually as some kind of outage. And we wanted to make sure that the benchmark works without these outages. The second requirement is 1 billion of active time series. The third requirement is the duration of the benchmark is 24 hours. This is much bigger compared to typical benchmarking benchmarks, which take from a few minutes to a few hours maximum. And if you multiply 100 million samples per second by the number of seconds in 24 hours, you will get that this big, huge number, more than 8 trillions of samples should be ingested during this benchmark into VictoriaMetrics. And here the configuration for the Prometheus benchmark itself. It contains of 16 load generators. Each load generator has 8 CPUs and 24 gigabytes of memory. Every load generator is set up to scrape more than 50,000 of node exporters. This means it scrapes like more than 50,000 of unique hosts, host metrics. And the total number of such hosts is more than 800,000. And every scrape target, node exporter in this case, exposes around 1,200 metrics. And if you multiply these two numbers, you will get that the total number of scraped metrics equals to 1 billion. And the scrape interval is 2 seconds. This means that every such target is scraped every 10 seconds. And if you divide 1 billion by 10 seconds, you will get the ingestion rate of 100 million samples per second. The configuration of the VictoriaMetrics cluster for this benchmark, which we came up when running this benchmark, we used the standard Helm chart for VictoriaMetrics cluster and run it in Google Kubernetes engine. The cluster consisted of 46 VM storage nodes. Each storage node has 16 CPUs, 55 gigabytes of RAM, and more than 2 terabytes of HDD-based disks. It consists of 18 insert nodes, and it has no any select nodes because the current benchmark measures only data ingestion path, and in the future we are going to present a talk for data querying path and for simultaneous data ingestion and data querying. We allocated 128 CPU cores for Prometheus benchmark loader itself and 400 gigabytes for this. For VictoriaMetrics cluster, we allocated slightly more than 1,000 CPU cores, 3.5 gigabytes of memory, or terabytes of memory, and around 100 terabytes of disk space. And all this Prometheus benchmark loader and VictoriaMetrics cluster were running on in the same Kubernetes cluster in Google Cloud. This Kubernetes cluster contained 36 nodes. Each node has 32 CPUs and 128 gigabytes of memory. The total number of CPUs in this benchmark is 1,152, and the amounts of memory is 4 and 6 terabytes of memory. These were allocated resources, and these are actual resources used by the benchmark. VMinsert used 200 CPUs and 26 gigabytes of memory. The storage used around 500 CPUs and 600 gigabytes of memory. And if we compare the allocated resources to the actual used resources, you can see that the benchmark was using around 70% of allocated resources and around 18% of allocated memory and around 7.5% of allocated disk space. This means that there is a pretty big amounts of memory and disk for running bigger workload on this allocated resource. I'm not saying about CPU. During the benchmark, the network usage rose to 140 gigabits per second in this cluster of VictoriaMetrics. This is a pretty huge number, and I was afraid that the limiting factor of VictoriaMetrics cluster scalability would be network, as I mentioned before, but this is not the case, and Google Cloud provides quite good networking, so it works. And actually this network usage can be reduced by almost 8 times to 20 gigabits per second at the cost of increased CPU usage at 10% by enabling data compression between insert and storage nodes. And by default, this data compression is enabled, but in this benchmark, it has been disabled. Okay. the disk I/O was 3 gigabytes per second write speed and 450 megabytes per second read speed. This is overall disk I/O on all storage nodes in the cluster. The result is that we achieved stable data ingestion performance at 100 samples per second during 24 hours. There were some spikes. These spikes related to spot nodes because we used spot instances in Google Cloud. These instances can shut down at any time and restart at any time, and there were some instances which were restarted, and they resulted in these spikes. We achieved 1 billion active time series per second, or 1 billion active time series. The total ingestion samples was more than 8 trillion. And the average sample size during this benchmark was 0.8 bytes. This is a screenshot from our dashboard of VictoriaMetrics cluster. Which takeaways we can get from this benchmark? The first takeaway is that VictoriaMetrics cluster capacity scales to more than 100 nodes. The second takeaway is that a single VictoriaMetrics cluster can handle metrics from 1 million of real hosts, where every host exposes more than 1,000 of metrics. Such takeaway is cluster stability improves with the number of storage nodes in the cluster. And it's interesting that this benchmark was running on HDD-based disks, not SSD-based disks, and the performance of HDD-based disks was enough for this benchmark, because VictoriaMetrics is optimized for disks with high latency. And the last point is that VictoriaMetrics handles large workloads without special tuning. You can use just regular configs and it just works and scales. You can reproduce this benchmark on yourself. Here are links to the benchmark itself, the benchmark configs and benchmark cluster configs. Later I will share this presentation with you, and you can click on these links and see. What's next? We can continue provide benchmarking, creating other benchmarks such as benchmarking query performance, increasing the load from 100 million to billion samples per second, increasing the number of active time series to 10 billions, adding the so-called churn rate to this benchmark, which is the main problem in Kubernetes. And we can run this benchmark for longer times, but it can take much money. So if I share your results of this benchmark, try running this benchmark on your setups, on your monitoring systems, Prometheus compatible monitoring systems, and share results. So that's all.
Thank you so much, Aliaksandr. Thank you. Thank you. Good on time. This is your present. Thanks for your contribution. Thanks for contribution at OSMC 2022. And yes, we're open for questions. So please raise your hand if you have any, and I will come over again with the microphone. Yes, I am coming, Markus.
Hi. So my question is, how did you figure out how many nodes you need in the cluster? Did you figure that out beforehand or by trial and error?
Yes.
And is that amount the minimum amount of nodes I would need for that amount of ingestion?
Yes, we figured out the number of needed nodes by trailing, and yes, this is the minimum amount of nodes in the cluster where this which can handle this workload.
Okay, yes, and there's one more question.
Sure. Thanks for the talk. That was great. Do you have any plans to implement any type of rebalancing or sharding across the cluster to deal with changes in workload?
Thanks for this question. This is a pretty common question, frequent question from our users. But the answer is twofold. We are not going to implement resharding and rebalancing, automatic resharding and rebalancing in the cluster because of it can reduce the stability of the cluster. For instance, if you have 10 nodes with 10 terabytes of data at every node, and you add 11th node, and you want automatic data resharding, this means that you need to transfer at least 10 terabytes of data to the new node. And this can take time, network bandwidth, CPU, disk I/O, and so on. And during this time, the cluster stability will suffer. That's why we are not going to add automatic resharding and rebalancing. But we are going to provide some tool for manual resharding and rebalancing. That's our plan.
Yeah, so the other option is using object storage as a shared medium to handle some of that. Have you thought about that approach?
Yes, we thought about this, and this quite great solution, and probably it will be implemented in the future. Yes.
Thank you.
Thank you. Any more questions? Oh, yes, coming.
Have you some experience in terms of performance in comparison with InfluxDB or ClickHouse? I mean, there has to be a reason why you created your own.
Yes, our history is that we were using Prometheus before starting VictoriaMetrics company, and the Prometheus, we reached Prometheus limits at that time. And we also were using ClickHouse at that time, and we thought that it would be great to create Prometheus-like system on the ClickHouse ideas, because ClickHouse is so fast and has lower overhead, and that's how VictoriaMetrics has been appeared. It is essentially a ClickHouse-like system built on top of, or Prometheus-like system built on top of ClickHouse ideas. And as for InfluxDB, InfluxDB requires much more resources compared to VictoriaMetrics when handling the same load, especially this related to memory. It requires at least 10 times more memory compared to VictoriaMetrics for handling the same amounts of active time series, not counting disk space and CPU.
Sorry, could you repeat that? Why did you use ClickHouse then? When you said you...
we were using ClickHouse not for monitoring, we were using it for analytics purposes.
So you, okay.
Okay, one last question, and then would you mind handing over the microphone?
I'm just wondering, what kind of resiliency or redundancy features do you have in this?
The redundancy, this benchmark has no redundancy. This means that every ingested sample is stored only on a single storage node, on a single location. And the actually redundancy is provided by Google Cloud disks. These Google Cloud disks are contain underneath of 3 or 2 copies of data, and they guarantee that the data will not be corrupted and will not be lost. That's why we don't use replication at the level of VictoriaMetrics. But if you need the replication at VictoriaMetrics level, we provide such solution, and you can replicate the data, so every incoming sample will be stored on multiple distinct storage nodes, distinct locations.
Perfect. Thank you so much. If there are any more questions, I'm sure Aliaksandr is more than fine with answering all those questions today.
Thanks.